Hi guys, welcome to today's lesson on the cosine rule, and it's also one used for non-right angle triangles, and we can use it to find side lengths as well as angles. Okay, here it is in its format used to find an unknown side length, C, provided that you know A, B, and the angle in between them, which is angle C. So to use this formula to find a side length, you need to have two sides that you know, plus the angle between them. Now here is the same formula that's been reworked around, or the subject's been changed to an angle this time. So this one's the one you use to find the angle of a non-right angle triangle. Okay, so if we have the same triangle as before, but this time we wanted to find this angle C, to do that we would need to know all three side lengths. So provided that we know all three sides, we could find an unknown angle. Now if you do look at the formula, the thing that you need to remember, because your triangles won't always be labelled A, B, C, is that in the formula, the part that's the minus, that is always the side length opposite the angle you're trying to find. So everything else, the A and the B are adding together, but the part that's minus off the back, the minus C squared, that is always the side length opposite to the angle you're trying to find. Okay, let's look at this example together. It says find the value of x, correct to the nearest whole number. Now, the x is a side length. Alright, so this means we're going to have to recall this version of the cosine rule. Now you might be thinking, where's my C's, where's my A's and B's? There's nothing on this picture, I've just got x. So this is when you need to know how the rule really works. That C is the x value we're talking about. Okay, it's the one we want to find. Now the A and the B, it doesn't matter the order you write them in, but the A and the B are these other two side lengths that we know. So that can be the 5.6 and that one can be the 6.4. And then we've got those two numbers being appeared here again, the 2AB. Then we've got cos C. Cos C is obviously the angle opposite that lowercase c, so that's the 112 degrees 32 minutes. Alright, so you can't just be remembering it as A's, B's and C's, because you've got to be able to work in lots of different scenarios. Alright, so let's write it out properly and we'll find ourselves an answer. So for this question, doing x squared. We said A we're going to call 5.6, so we're going to square it and add it to the square of 6.4. Then you take away two lots of 5.6 times 6.4. You'll note those numbers that we've just used squaring have appeared again. Alright, that's another way you can try and remember it. Times cos 112 degrees 32 minutes. Alright, so this we can go and enter in our calculator and get a numerical value for that right hand side of the equation. Okay, and that'll give you an answer of 99.789, and I'm just going to indicate that's an ongoing decimal number. Now if you're not getting that in your calculator, got to remember you've got to use that degrees, minutes, second button for your angles because it's in degrees and minutes. And then if you're still having troubles getting that right value there for this part of the equation, maybe start by separating, just doing these parts first, and then take away this back end if it's too much to enter into your calculator. Alright, however, we're not quite done yet because this value we've written down, and I haven't cleared it from my calculator because I know I'm going to use it again, that's x squared. So now, just like Pythagoras, we've got to go back and think about when we're in year 8 with Pythagoras, we want just x, so the opposite of squaring x is to square root. Alright, so that's why I kept that number in my calculator. I didn't round it because now I'm going to get the square root of my answer. There it is, and we want it to the nearest whole number. So there we go, 10 units. Okay, in this next example, we're asked to find an angle, this time theta, and then just round our answer to degrees and minutes. Alright, so obviously we're going to have to use the cosine rule in the angular version, where we're after that value of C, the angle C, which is our theta. So we look at our formula and we've got a squared plus b squared minus the c squared. So this minus the c, that's the side that's opposite the one we want to find. The other two sides, a and b, can be 5 and 6. All right, let's start writing this one out. So we're after cos theta. That's what we're looking for in the question. Now, a squared, so we can say 5 squared plus 6 squared minus, that's the important one, 3 squared. It's got to be opposite the angle you're looking for. All over 2 times 5 times 6. You get to reuse those two arms that are in between the angle you want to find. All right, and so that value will give us cos theta, and we want just theta, so we're going to have to use that shift cos, right? Again, whenever we're finding an angle. Okay, so let's go and enter in that whole big fraction and see what answer we get. All right, we get this value 0.86 repeater, all right, for that top fraction. So now we've got to go and press shift cos of our answer button. Okay, time for our third and final example. This time it says evaluate angle BCA. All right, so this means we've got BCA. The C is the middle point, so it means it's the vertex. So we're trying to find really angle C for this question in degrees and minutes. Okay, so again, we're going to be using this cosine rule in angular form. We're trying to find angle C. Now, most important part, we're looking at the corresponding side to angle C, and it's 8.4. So that's going to be our C squared in this formula. Okay, so again, it doesn't matter which order you do the A's and B's in. I'm just saying 4.5 squared for A and 6.1 for B minus 8.4 squared all over 2 times 4.5 times 6.1. All right, so that value we can now go and put in our calculator, because we're going to press shift again because we're finding an angle, so the inverse of that value we're going to find right now. Okay, so there we go. We've got that value in our calculator. We're now going to press shift cos of that answer and get 103.804 degrees. All right, degree minute seconds, 103 degrees, 48 minutes and 17 seconds. All right, we need to round it to the nearest minute. So 17 seconds is less than half a minute. So there we go. 103 degrees and 48 minutes is our final answer. Hope you enjoyed that lesson. You can now go and do some more practice from your set questions you've been given. Remember, if you have any troubles, ask for help on Google Classroom.